Since the end of 2019, the world has faced an unprecedented challenge with the outbreak of COVID-19. Originating in Wuhan, China, this novel coronavirus rapidly spread across continents, impacting millions of lives and overwhelming healthcare systems. Scientists and researchers worldwide have been racing to understand the virus, analyze infection trends, and develop effective strategies to mitigate its impact. One of the most critical needs has been the ability to predict the number of new daily cases, recoveries, and deaths. Accurate predictions help governments and healthcare providers prepare resources, implement timely interventions, and ultimately save lives. In this context, data science, artificial intelligence, and machine learning have emerged as powerful tools, enabling experts to analyze vast datasets and forecast the pandemic's trajectory. Let's explore how these technologies are shaping our response to COVID-19. Artificial intelligence and machine learning have played a pivotal role in analyzing and visualizing the COVID-19 crisis. Researchers have developed various models to predict future cases, deaths, and recoveries. For example, studies have compared linear regression support vector machines and exponential smoothing, finding that some models like exponential smoothing offer more accurate predictions. Egypt and the top 10 most affected countries, machine learning models have been used to forecast daily infection rates, helping authorities make informed decisions. These models rely on large datasets such as those provided by the World Health Organization and use advanced statistical techniques to identify trends and project future outcomes. By leveraging these tools, countries can better allocate medical resources and implement effective public health measures. Novel prediction model presented in this research combines mathematical and statistical methods within a supervised machine learning framework. The process begins by collecting data on confirmed cases, deaths, and recoveries. The dataset is split into training and testing sets, typically 80% for training and 20% for testing. The model calculates the number of new cases each day, the rate of change, geometric mean, and standard deviation. These metrics help estimate the expected number of new cases and set upper and lower boundaries for predictions. The model's accuracy is evaluated using metrics like mean square error, MSE, and correlation coefficients. When tested on Egypt and the top 10 affected countries, the proposed model outperformed the Bayesian ridge regression model, providing more reliable forecasts. This approach enables governments to anticipate outbreaks and respond proactively. Results of the proposed machine learning model are impressive. When applied to Egypt and the top 10 countries most affected by COVID-19, the model consistently delivered more accurate predictions than the widely used Bayesian ridge regression model. The mean square error, MSE, values were lower for the proposed model across all countries, indicating better performance. These accurate forecasts are crucial for governments and healthcare providers, enabling them to prepare resources, adjust public health strategies, and potentially save lives. The model's ability to adapt to different countries and changing infection rates demonstrates its robustness and versatility. As the fight against COVID-19 continues, such machine learning approaches will remain essential tools in managing and eventually overcoming the pandemic. The heart of this prediction model are supervised machine learning regression techniques. Regression models are used to analyze the relationship between variables and predict future outcomes based on historical data. In the context of COVID-19, regression helps estimate the number of new cases by learning from past trends. Techniques such as linear regression, support vector machines, and Bayesian ridge regression each have their strengths and weaknesses. The proposed model enhances traditional regression by integrating statistical measures like geometric mean and standard deviation, improving prediction accuracy. Understanding these concepts is essential for appreciating how data-driven approaches can inform public health decisions and help manage complex crises like a pandemic.